So today we are going to learn digital electronics as we said in previous intro class. So in digital electronics, this is the first chapter, first subject that we are going to learn in VLSI, that is digital electronics, which is basic for the BTech students also. So in this we are going to learn gates. What are these gates? Where we use these gates? We are going to learn. So in these gates, the first gate that we'll get is, basic gate is NOT gate. See, simply drawing this is not a gate. Giving the naming is a gate. So here we are giving A. The output we'll get is A bar. Input is A, output is A bar. No, nothing but complement of input. If we are giving A is 0, the output will be the 1. So this is known as the complement of the input. So the truth table for this is, based on this we can see. So A bar is the what? Output, right? So if A is 0, it is a single digit. So electronic components, machine components, it takes only binary numbers 0 or 1. So if A is 0, then A bar will be 1. If A is 1, A bar will be 0. This is known as NOT gate. What it is? NOT gate. Or you can say it is inverter also. What you can say? Inverter. And second thing is, second gate that we are going to learn is OR gate. OR gate. ORing is nothing but adding binary numbers. Okay, adding binary numbers. So binary numbers is 0 1. We have combinations 0 0 0 1 1 1, everything. So OR gate. So OR gate is, it is like this. Well, I'll show you. Okay, like this. Oh my god. Here we'll have 2 input and 1 output. Output is Y. Y is nothing but A plus B. Adding. A is one input and B is another input. So OR gate will do ORing. So here we'll have combination of 2 numbers, 2 binary numbers. So the truth table is, so we have 2 input A, B and Y. What is Y? A plus B. Okay. Now based on this, we will get to know the operation, how this OR gate is going to work. Okay, first is 0. If A is 0 and B is also 0, 0 plus 0, what it will give? 0. Okay, if A is also 0 and B is also 0, then it is 0. Next, if A is 0, if we say B is 1, A is 0 and B is 1, 0 plus 1 is what? 1, right? If A is 1 and B is 0, then 1 plus 0 is also 1. Next, both are 1. 0 plus 0, 1. 1 plus 1 is 2, as we know basically, but in binary representation of 2 is 1 0. So 1 plus 1 is 1. Okay, so how we will describe based on these truth tables? See, if A is 0, one of the input is 0, right? If one of the input is 0, output you should not do like 0 plus 1, 1 plus 0. You can say that the output will be the same as the other input, B1. And one of the input is 1. So the output will be the complemented. Complemented is nothing but B bar. So same as, it is not complemented. We have got 1. So we'll say that it is 1. Output will be the 1. So 0 is low and 1 is high. Okay. Next, ORing, adding is happening. Now multiplication, that is AND gate. What it is? AND gate. Third gate. So third gate is AND gate. How here also 2 input. So but representation is something like this. A, B. So y is equal to A dot B. Now based on truth table we are going to describe this. A, B, y. Okay. If A is 0, B is 0, A into B, 0 into 0 is 0, right? Okay. A is 0, 0 into 1 is 0. Next, 1, 0. 1 into 0, 0. 1 into 1, 1. So this is the truth table of AND gate. So you can see that whenever the both inputs are high, then output will be the high. If we are going to say the switch, if both inputs are high, then only switch is going to on. If both inputs are low, or if any one of the input is low, then the switch will be the off. Like this in general language we can say. And another we can describe here. See here, if one of the input is 0, any A, here we came to know that A is 0. Then whatever may be the B, it may be the 0, it may be the 1. B may be 0 or B may be 1. Then what is the output? Same as A, that is 0. Right? Next, if one of the input is high, that is 1. If A is 1, output is same as other input. What it is? A, B. Whatever the B we got, same we got here. B is 1. We can say, so if one of input is 0, okay, then output is 0. This is first point. And next, if one of the input is 1, the output is same as other input. That other input is nothing but B, right? Whatever the B value we got, that will have. This is AND gate. AND gate is finished, OR gate is finished. Now we'll go with the complementing of this NAND gate. What it is? NAND gate. So basically NAND gate is complemented of AND gate. So AND gate basically we describe like this, right? A, B and y is equal to A dot B. The difference between AND gate and NAND gate is we'll have here a bubble. I'll give you, see, this is a bubble. This is called inverter bubble. So output will get complemented. So expression will be A dot B bar, means If we get output is 0, 0 bar means we will have 1. Totally quite opposite to AND gate. So we will go with truth table. Truth table, right? This truth table is nothing but A, B, y is equal to A dot B whole bar. Okay, 0, 0. Y is equal to 0 dot 0 whole bar. 0 into 0 is 0. 0 bar will get as 1. So y is equal to 1. Okay, if 0 and 1. A dot B, 0 into 1 is 0, but complement of this is 1. Like this we are going to describe. 1 into 0 is 0. 0 bar is 1. 1 into 1 is 1. 1 bar is 0. This is the truth table of NAND gate. As we are comparing the truth table of what we say AND gate. So here we got 0, 0 is 1 and here we got 0, 0 is 0. So, and here we got 0, 1 is 1, here we got 0, 1 is 0. So same quite opposite to. They will say if one of the input is 0, then output is 0. Here see, if one of the input, your input is 0, right? A is 0. What is the B? B is 1. Okay. If one of input is 0, output is 1. No matter of whatever may be the B, output will be the 1 if input is 0 in NAND gate. And next statement is if one of the input is 1, output will be complemented of second input. Okay, if one of input is 1, output will be complemented of second input. Okay, this is first one. This is NAND gate. Next, NOR gate. As you know, OR gate, right? This is the OR gate. A, B, y equal to A plus B. Same, here we'll give a bubble which will give the complementing. So A, B, y, 0, 0, 0, 1, 1, 0 and 1, 1. So A plus B whole bar. 0 plus 0 is 0. 0 bar will be 1. 0 plus 1 is 1. 1 bar will be 0. 1 plus 0 is 1. 1 bar will be 0. 1 plus 1 is 1. This is quite opposite to OR gate. OR gate whole bar. Okay. Here, if one of the input is 0, output will be the complementing of second input. If one of the input is 1, output will be the 0 no matter the second input. So, if one of input is 0, output is complementing its second input. If one of input is 1, output is 0 no matter of second input, whatever may be the second input. Okay, this is the NAND gate. So far we have learned today AND gate, NAND gate, OR gate, NOR gate. NAND is complementing of a OR is NOR is complementing of a interconnected and in NOT gate. So in next video we will going to learn what is universal gates and more number of gates, whatever more number of gates we have. So thank you for watching.